Hi everyone. Welcome to session 4, Industry Applications. This is our last session for the DCIO 2021 conference, and I'll be discussing, tools and applications in the industry and how they are changing, what is the frontier, what are the frameworks, the platforms, and how this is evolving. So for our first presentation, we have a recorded presentation from Kean. I'll make a brief introduction. So Kean Walmsley is a software architect working on projects that integrate IoT data with BIM, sometimes called digital twins, via the Forge platform. As well as working on generative design in the AEC space. He has worked in various roles and in various countries during his career at Autodesk, including building and managing teams of software developers in Europe, the Americas, and Asia Pacific. Kean engages regularly with Autodesk's developers and computational design communities, providing technical content and insights into technology evolution.
Many thanks to Abel for inviting me today to speak to you about the past and future of digital twins at Autodesk. So my name's Kean Walmsley. You can find me at KeanW on Twitter, keanw.com. You can also find me at KeanW on LinkedIn as well. And you have my email address there should you have any questions. So very briefly, a little bit about me. So I've joined Autodesk in 1995. So I spent many years in the developer network team in a variety of roles in a variety of countries. I moved across into the AutoCAD team as a software architect in 2012. And since 2016, I've been in our research team. And just a little bit about my movements around the world. I started in the UK, have done two tours in Switzerland and the US and India in the middle. Since 2006, I've been writing a blog to help people with developing with AutoCAD originally, but since my role has changed, I've spent more time talking about my explorations using Forge to create digital twins, to integrate IoT data into BIM. So a little bit about digital twins at Autodesk, at least at Autodesk Research. So previously, this was a slide where we'd sort of talk about Project Dasher and how it came about. So we tend to think, broadly speaking, of digital twins as having some 3D geometric representation. Now, lots of people think about things differently, but we're a 3D centric company, so that tends to be why we think that way. Plus some control behavior, allowing you to actuate things in the real world, measuring data from the real world, plus the ability to sort of predict into the future via simulations and then other predictive tools. So all of these come together in a digital twin. Now, Project Dasher really only takes three aspects of this. So we take the data coming through Forge for the as-built BIM, we take data from the BMS and IoT sensors, and then we have a number of tools to help you explore that data in 3D. And these contribute to be what we kind of think of as a building debugger. And this is Project Dasher. So originally when we started Project Dasher, it was late 2009, beginning of 2010. So it was a desktop application. This is the first kind of iteration of that tool, using a number of sort of internal Autodesk components. So it was the idea, of course, is that we would bring in data from a time series database where we're storing sensor data and contextualize that data in a 3D environment, allowing you to explore the power consumption for an individual cube amongst or a whole floor or a whole building, but really start to understand how your building is performing and what changes might be needed to improve its efficiency. When we presented this work, we did an integration with a building for NASA. So that's the logo in the bottom right that's been masked out for copyright reasons. We took several thousand or a couple of thousand sensors in the NASA Ames Research Center in California and integrated those into Dasher. This is a, a visualization in the web-based tool, but originally, of course, we worked with them with a desktop tool. Now, when they first saw this visualization, there was a few things that stood out to them. So firstly, there's this central area, which is a lot cooler than the rest of the floor, which they said, okay, well, that's where the servers are stored. That's our data center, so it's normal that it's cool. But then they also took a look at this area of this floor and realized that this room was quite a bit cooler as well. And it was at that point that somebody sort of stuck their hand up and said, well, actually, this is where we're doing a glazing study, an experimental study. I believe it was some sort of glazing, some film on the windows, but essentially they could see immediately from the data that was having an effect. They hadn't yet crunched the numbers on the study itself, but they could see from the sensor data that this was, at least in some ways, effective. Moving on from there, we had a collaboration with Schneider Electric, who, excuse me, in this case, for a building of theirs in the south of France, they integrated a number of sensors which allowed you to detect the position of people in a space. So here we're turning on these sensors, and you can see these kind of purple Playmobil people that are effectively showing where the occupants are in a space. And this presented some really interesting opportunities in the sense that we could start to correlate information that we have from other sensors with these occupancy sensors. So here we could see, well, let's see where there's a spike in CO2 levels in a particular conference room at a certain time of day, and then start to understand why that is happening, how frequently that happens. So, once we've seen, well, this event is happening, we can see that the CO2 levels have spiked, we can pull up an individual sensor and then zoom out on that data in order to determine the sort of approximate frequency of how often this kind of thing happens. So here we're basically zooming out on the data, and we can take a look at a large time period at the same time and say, well, okay, is this something that we need to modify the BMS to manage, or is this something that's a freak occurrence? We've also collaborated with the NEST project. So this is the experimental building on the outskirts of Zurich. So this is a collaboration between EMPA, the Swiss Material Sciences Institute, and ETH Zurich, and it's really a test case for a number of digital fabrication techniques. So we've integrated, once again, data from lots of sensors that they already have inside their back-end system, and we were able to sort of take this data and pull it into Dasher. So here we're just sort of stepping through and taking a look at some of the sensor types that are available. This is just a standard sort of run through of different Dasher features. And here you can see we're hovering over different sensors, bringing up the data. We can skip forward a little bit. We have the ability to zoom to different views that have been stored in a dashboard, and then we can also essentially map the data for a particular location. We can take the first floor of the building and map the sensor data onto that floor and animate that over time. So here we can see that it's essentially animating the sensor data over a particular time period, and we can see the variations live as we're doing that, just as we saw for the NASA building. So here's another quick sort of graphic showing sort of multiple different visualization capabilities at the same time, showing various data sources, allowing you to correlate this data in an interesting way. So having done various projects on the BIM side of things, looking at buildings, we started to explore more on the infrastructure side of things. So this is an office of ours in San Francisco, the Pier 9 office, and this is a raised walkway that connects a couple of areas of the office, and we can go between the two spaces using this walkway. Now, in order to test out some technology for a different project, we instrumented this bridge with a number of accelerometers, strain gauges, inclinometers, various sensors that would give us a sense of how the bridge was performing. Here we can see we sort of entered a 3D view And if we go down to the next video, we can see that we're actually able to integrate video footage from the bridge, from cameras that have been set up at either end of the bridge, in order to get a better sense of what is happening on the bridge at any particular moment in time. And so here you see a security guard crossing the bridge early in the morning. We can zoom in on the data and literally get down to the point where we're understanding his individual footsteps. Now, while it was very interesting to have access to this data and allow us to visualize it and to make sense of the data, it's not necessarily ideal to have lots of people have access to a private information such as video footage. So we started to do some explorations using computer vision to blur out faces, to extract anonymized skeletons from video in order to start to make sense of this data, and then to map that data back into 3D. So here we are with a sort of a 3D skeleton. It's actually 2.5D in the sense it's in the plane of the camera frustum. But we've done some work to improve that and make it properly 3D. Now, the reason we were doing this was really for the MX3D project. So this is the world's first 3D printed steel bridge made by robotic welding machines. So the original vision was, of course, to have, or not of course, but was to have robots printing their way across a canal in Amsterdam. Now, ultimately, this wasn't realistic for lots of reasons. So the vision shifted somewhat to be inside a warehouse on the NDSM wharf in Amsterdam. So in reality, so Autodesk was involved quite early on conceptualizing the project. We weren't involved in the design work. Ultimately, the design process shifted to a more sort of aesthetic look rather than being generatively designed, which would have been, our initial focus on this. So here's the bridge kind of being constructed. It was also, not necessarily constructed in completely in this sense. There's a number of sections that were printed vertically, of course. Here's the members of the team doing an early kind of stress test on the bridge. This is after there was tens of tons of water had been put on the bridge as a proper load test. So this was just a bit of fun, really. So our job as part of the MX3D project and part of this team was really to help instrument the bridge with sensors. So along with a number of other industrial partners who collaborated on this, industrial and academic. So the idea, of course, is that we give the bridge some intelligence or some smarts, effectively creating a piece of smart infrastructure in the middle of Amsterdam. So we had a number of periods where members of the team went across to Amsterdam and were involved in running cables and soldering. So it was a very hands-on project, I would say. The big unveiling for the project was at Dutch Design Week in Eindhoven in late 2018. So here's the bridge. It won various awards from this as People's Choice. What's interesting is that a lot of people really, obviously enjoyed seeing the bridge and understanding that it was a very aesthetic, beautiful object. They also appreciated that it was 3D printed, but it was really a very small section of the public who got a sense for how interesting it was that the data was being collected from it. So here we can see a little video where some colleagues from Imperial College were sort of jumping up and down on the bridge and seeing the effect via various sensors that were captured inside a streaming dashboard. So here's a quick visualization of some of this data inside Dasher as we're zooming around, taking a look at it. We're also able to visualize this data visualize the camera data alongside it as well. Sorry, I have a slight problem with my video playback. So here we're seeing again these 2.5D skeletons that have been extracted, and we can hit play and see the skeleton footage alongside the video footage and start to compare the two and understand where things align and where things don't. In fact, one of the cameras had an inversion, but it's only you'd be very lucky to spot that, I think. Ultimately, of course, the idea is that we're able to then show skeleton data alongside this, the stress data that's captured from the bridge, and that's really an important future aspect of this project. The infrastructure is in place. The good news is that
this is cool.
Well, anyway, I'll play this video. This is a quick video that we took in Amsterdam where we showed the skeleton data streaming in real time off the bridge for the first time. So I'll let you watch this.
Oh, you just bring the computer over. Exactly. Watch out. All right. So let's see. Are you there? Can I? Oh, hang on. I need you to just turn up the brightness. Oh, yeah, it's kind of hard to see. Yeah. Let's see if I do it in here. Then maybe there we go. Can I see the bridge though? Yeah, go. Okay. All right. This is cool. So all being well, we are going to see Mike going across the bridge in real time. Yeah, I think so. It's yeah. I can see you. All right, we need one more person on the bridge. Go on, get on the bridge. More people on the bridge. Oh, this is amazing. Oh, this is amazing. Well, anyway, that is super cool. I hope you agree. All right.
So that was a big moment for the project in the sense we were able to stream data in real time off the bridge and see the skeleton, do the real time computer vision, crunching the data and displaying the results. So since then, of course, that was 2018, so a long time ago. Since then, despite COVID and everything else, finally the bridge has been placed across the canal in Amsterdam. So this is from just a few months ago. This was the Queen of the Netherlands, Queen Maxima, who came and performed the official ceremony. There was a robot that actually cut the ribbon, of course, because robots. I was there. This is the back of my head at the bottom of the screen here, so I was happy to be able to participate, considering that I'm based in Europe. I was one of the few members of the project team was the only member of the Autodesk project team who was able to get across for it. So I was very privileged to have been there. Now, obviously, the next step is that we start to take this, all this data and start to be able to visualize the camera data. We're about to install the cameras. That has not happened quite yet, but it's a work in progress. We have discussions ongoing with the city of Amsterdam, and I'm hoping that at some point we'll be able to turn on the computer vision and then start to display these fully 3D skeletons now. We're using a different technique to pull out proper 3D from the skeleton data. You can also see here on this view we've integrated the ability to display multiple sort of heat maps at the same time, so you can start to correlate multiple data sources, not just through a single sort of 3D heat map. So there's various things that are going on inside Dasher to enable this project. So in terms of research, so Dasher obviously is about monitoring, it's about IoT. There is a bigger picture involved here, and this is really about closing the loop on the design process, whether it's a generative design or a manual process. And the idea here is that increasingly as we monitor the real world via sensors, etc., we can start to feed that data back into the design process to improve the quality of future designs. So eventually, we'll be able to take this data, and we have a few projects where we're starting to see that come out, but the sort of data that we're capturing via digital twins, via IoT, is definitely going to enhance the quality of designs in the longer term. Now, in terms of where things are with this technology, so Project Dasher is a research project. Now, there was a recent project by the Forge team called Project Hyperion, and it's very much inspired by Dasher. And now Hyperion has kind of graduated to be part of the Forge Viewer. So if you want to explore the data visualization extension in the Forge Viewer, essentially you'll be using pieces of Dasher that have been built into Forge. We're also exploring the ability to for customers to be able to create digital twins themselves without necessarily programming. So this is a project or a product called Autodesk Tandem. It's in its early stages. It's been available now for a number of months. Its focus is very much on the idea of digital handover and improving kind of the quality of this, what is today a very fragmented process. So even for Project Dasher, every time we've done a project, we've had to use an as-built model that was quite expensive to create. So there's what the Tandem team is really trying to do is to increase or reduce the friction in that whole piece of the process. They tend to look at digital twins. Well, there is a diagram that has been created by Vedantics, which I think creates shows a nice frame for digital twins in general. Now, to give you a sense, where Tandem is right now is a descriptive digital twin. Over time, they're really aiming at that green area where they can start to become an informative digital twin where things are connected, and then a predictive twin where we start to think about simulation and integrating that into the digital twin. But right now, it's still relatively early and it's a descriptive twin. Tandem manages assets ultimately. So you have assets in an AEC project. You have assets that are part of systems, they're part of facilities. You have spaces as well that, in a sense, are assets too. So these are all things that need to be managed by the system. Now, in Tandem, for the moment, you have this idea of all the context that comes in from BIM models, for the moment from Revit, in the future IFC as well. You can tag these assets and essentially manage them as part of the digital twin. So that's something that's happening. And then in the future, as they start to integrate more capabilities, such as we've seen in Dasher, then we'll start to see connected assets where you can really manage assets that are connected to the real world through sensors. So you can start to bring in sort of sensor data or telemetry data into Tandem and manage that. So this is something that we're increasingly seeing, and the Tandem team is working very closely with the Dasher team to start to understand what is possible and what pieces of Dasher should be taken across. So that's it for my presentation. Thank you very much for paying attention. If you'd like to reach out and get in touch, please do send me an email at my email address. You can connect on LinkedIn, follow me on Twitter, and I also have my blog at keanw.com. And I look forward to hearing from you. Thank you very much.
Thank you, Kean, for the fantastic keynote for this industry application session.